All right, good morning. Happy Tuesday. What is up to Liz in the chat? Nice to see you today. Let me shuffle around a few more of these windows, which are out of control. All right, there we go. Here's this. Welcome, everyone. For anyone who's new or doesn't know, actually, 1 second here. Let's do one more thing. There we go. All right. For anyone who's new and doesn't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. And I stream around this time each week, 10 a.m. on Tuesdays here on the Adafruit channel, working on stuff generally related to CircuitPython. If you don't know what CircuitPython is, you'll learn more about it at the main website for the project, which is circuitpython.org right here. This is basically a version of Python that runs on tiny computers called microcontrollers. When you use CircuitPython on these devices, the way it works typically, you'll plug it into your computer with a USB cable. It shows up like a thumb drive, and then you can edit a Python code file on that thumb drive. When you save it, the microcontroller will execute that Python code for you. So that is the very, very high-level quick version. Again, circuitpython.org, you can learn more. Also encourage you to join us in the Discord. There's folks discussing the development of CircuitPython and projects using CircuitPython and all kinds of other fun stuff. CircuitPython is open source. Anyone's allowed to use it. Anyone's allowed to put it on your own devices, use it for whatever you want. If you are a hardware manufacturer or designer, you can design your own devices and add support for CircuitPython to them. You don't have to pay a licensing fee or any kind of thing like that. It's all open source, free to use, and that is made possible by Adafruit. They pay a team of folks, including myself, to work on this CircuitPython project, as well as some folks who work on other open source things outside the CircuitPython world. If you would like to help support CircuitPython and all the other open source work that they do, one of the ways you can do it is by purchasing hardware from them. You can do that at their website, adafruit.com. You can get yourself microcontrollers that run CircuitPython, as well as some that don't. You can also get yourself all sorts of other sensors, bits and bobs, lights, buttons, beepers, buzzers, any kind of little electronic widget you could imagine, pretty much, that you can hook up to a microcontroller to control from CircuitPython code or any other kind of code. You can get those things over at the Adafruit store. And as the banner is here as a great reminder for us, JP's product pick will be coming up later today, 4 p.m. Eastern time. So you can not only get some goodies that you can use CircuitPython and other microcontroller programming with, you can also get it at a nice discount later on today for the particular picked item of the week. What is up, Royal Bengali over in the Discord, how to install it. So on the circuitpython.org page, if you go to downloads and you choose whatever device you have, so if you have a Raspberry Pi Pico, you click this one, you click download UF2 right here. On your board, what you will do is hold the boot button while it turns on. This one doesn't have a reset button, so you just have to unplug it, hold the boot button, and then plug it back in. It's going to show up again like a thumb drive, but this time it will have the name RP, it's like RPI, RP2 or something like that. And you will copy this UF2 file that you download from this button right here. You just copy it onto the board. It will take a couple of seconds to transfer, and then it will reboot when it's done. And when it boots back up, it will boot straight into CircuitPython with the CircuitPy drive. I would encourage you, if you do want to, if you've never used CircuitPython before and you want to learn more, this guide right here, Welcome to CircuitPython, I'll drop a link for it in the chat. This is a good place to start. And again, also, I encourage you to join the Discord. There's Help with CircuitPython channel there, where there's folks who are happy to help people get spun up. What is up also on YouTube to Peter Huseman? Nice to see you, my friend. I want to make one. I'm using FPV. Is making an FPV drone very hard? So I don't know very much about the drone things. I would imagine it's somewhat difficult, but I don't have any experience with drones. You might try to catch Scott on his deep dive on Fridays. I know before he got into Adafruit doing CircuitPython stuff, I believe one of the things that he was working on was quadcopter drone stuff. So he may have more insight into that than I do. Certainly you could use microcontrollers on quadcopters, but I don't know to what extent there are people using CircuitPython out there for it, nor do I know any of the other specifics about, motor controllers and all the stuff that goes into quadcopters specifically. So diving in today, I've been doing a bunch of work in the Zephyr port, and I am back there again. We are going to enable the Adafruit bus device, which is a core module that implements the same thing as a Python module. So there is Adafruit bus device as a Python library. Right here. So you can install this in the lib folder, just like any other CircuitPython library. It is Python code inside of here. But there is also a core module implementation of this. If we look in shared bindings, Adafruit bus device, we have C code that implements the same thing in C instead of Python, which makes it faster. So I actually had a branch where I did this, and I thought that I committed it, but it seems like I messed up the Git situation, and so it was not actually committed there. If I'm recalling correctly, the only thing I really had to do to get this enabled was just add it to this list here. So for some modules, I've been able to just add them to this list, and that's it. You don't have to do anything else. I've been writing tests for them as well, so that's like a thing to validate that it's working. But some of them you just add to this list. There's no other changes to get a build, and it just works. Others of them, I've enabled them here, and then it requires some other changes in various other places to either get it to pull in the right code or to get it to enable the right thing. I don't remember on this one, so we're gonna find that out together. So I'm gonna first ls because I want to get the name of this without having to remember it. That's actually not the one I want. I want this one. So we're going to make the Feather RP2040 first because that one I just have here ready to test. We do need to be in the virtual environment. I'm not there right now because this version of the project doesn't remember it for some reason. Somehow I set that in the other one. I'll have to figure out how I did that. I think Python interpreter somewhere. While that's running, we will click over to here. I do not have a device plugged in currently. I will plug this in. I have a Feather RP2040 here, and it is connected to an I2C sensor. I don't have the camera set up today, so y'all can't see it, but I promise you there's really nothing to see. It's just a Feather with a stemma cable and a sensor. Reload this. We're not doing lights or anything interesting visually. There's no displays or anything fun, so. Unified matrix. Are we on the Zephyr port here? Yeah, okay. Zephyr port. Okay, so this unified matrix thing, this is a totally different thing I was working on. Which I guess I tested on this Feather. I'm not actually sure if I intended to ever run this on this Feather or not, but maybe. In any case, it's here, so I'll keep a copy of it. I have it on other devices as well, but we're gonna be writing CodePy. No, we failed. Okay, what is this? What else did I have to do? Undefined. My clean not work? Or was this the one where I had to enable... It's not the right folder. Might have had to put something in here. Tried to commit this to be able to get back to it, but failed in actually committing it. Now I've reverted, I think. I don't think we needed that stuff for this. It was back to not here. Okay. All right, unfortunately, we got to troubleshoot the build real fast here. Let's see. So I think, I mean, a lot of this stuff succeeded. Did my clean exited with this? LD returned 1. Definitely just linking is not working or whatever. I think it needs something else enabled somewhere. And I do not remember off the top of my head what it is. 1 second, actually. I need to do something else real fast. I'm gonna do this. Alright, sorry, we're coming back in just a second. Whoop, that's not how you spell that. Okay, here we go. Alright, we're back. Occurred to me I had a thing open that I did not want open. Yeah, okay, so we were also gonna do this real fast. I wonder... Well, it's not going to be in the root, though. Oh, showed me all kinds of other ones. Interesting. That's not very useful. Oh, that's annoying. Is it just always going to do that? That is not what it used to do. Okay, that's wigging out. I used to be able to go to a directory, run Claude resume, and then it would only list ones for that directory. But this is listing all of them for every directory. There's Control A, only show current repo. But is current repo current folder or current repo? I don't like how you have to Control C twice, and I also don't like how this like paints over your terminal after it runs. Okay, we'll try here. I don't know if it's going to be here, honestly. If I could find... if it failed to build the first time, then I would have... Okay, that's really annoying, actually. I wish it would not do that. Nordic, disabled modules, message pack. I hope they will change that. That's so awful. Okay, anyway, I don't know. If it would have failed to build the other day when I did this, I would have most likely just asked this thing and gotten help with it. Alright, last one we'll try. I don't think it's going to be here because I'm pretty sure this one is too new. Yeah, zlib. I don't know. Maybe I did. I don't really remember having trouble building it before. Maybe I didn't. Let me try a clean again. It would be a shame if we just didn't get it clean and that's why it didn't work, but most likely we still need to enable something somewhere. I think. Trying to enable or module. Okay. I'm almost positive the answer is going to boil down to like add a thing into another file, either enable a thing or add it to be able to pull in the right code. I don't know why. It doesn't really most likely need to read I2C device, but we'll let it slurp in the context that it wants. But I do think the answer is going to be like basically just add it in one more place. A flag or a yes or a true or something like that. Sure. Build scripts. Only, yeah, okay, the glob thing. I do remember this now. Yeah, yeah. Yeah, actually, let's let it. I think it had to do it in two. Did it have to do it in two places? No, it didn't. Okay. I do totally remember this now. Yeah. So it basically, the way these globs, I guess it did need to read those folders, or it makes more sense why it read those folders now. I think the deal is because in shared bindings and or modules, I'm not sure if both matter or what, but these subfolders here, I think we're not getting pulled in. Most modules, like if we look at bitmap tools, there's no subfolders, or display IO, there's no subfolders. Most of them don't have subfolders, but this one does, and that breaks because the code further down here was not expecting it, and I do totally remember making this fix now. These two globs. Unfortunately, it's a bit of a pain to copy out of here. Maybe we can do this. And it is the same for both of them. So that's after the curly bracket and inside the double quote. There we go. Okay, so the way that globs together now, it will grab folders as well. So let's clean, try the build again. And then this will also still hit individual files, I believe. There must be a Claude session somewhere that has this. I don't know where. I don't know why we didn't see it in any of those. Maybe it was in one of the other ones. Maybe I didn't make a new one for it. And so the last message was about something else in the list. That could be. Could be. Which I guess the error did kind of tell me, didn't it? Right? Because that error was like, can't find I2C device. Undefined reference to Adafruit bus device I2C device. So specifically the subfolder inside of bus device is what it failed on. So it does kind of make sense there. Okay, we got a successful build. So we can put it on the device by holding boot and pressing reset and then copying the UF2. Zephyr CP, Zephyr, and then Zephyr.uf2. RPI, well, this is RP2 one. Is that the same? No, I think the original one would be something different for the person who asked about how to load earlier. And I was using the Pico. No, this is RP2040. Yeah, it would be the same on the Pico, actually. Okay. While that is copying, we are also going to go get the simple test for X44009 because this happens to be the sensor on my desk. One of the sensors on my desk, let's be honest. Right now that I am working on, so I happen to have it here and easy to plug in. Let's save this. Okay, there we go. So that's reading stuff. Very good. Let's make sure though. Okay, yeah, so Adafruit, so not Adafruit bus device right here. Oh, no, actually I have another copy. Let's delete this. I think it would, I'm pretty sure it would take the core one anyway, but we should delete that first so that we can be absolutely sure we're not using the Python implementation. And indeed, that's now gone. This one has not in the name, so it would not get imported. And this code is still working, which uses this driver. Inside this driver, it uses register and bus device to read from the sensor. So if bus device were not working, then this would not be working. And so that is good to go on a manual test. So the next thing I want to do, though, is get the automated test going. And for folks that don't know, the automated tests for Zephyr happen on the native sim, which is one of the boards that you can build. So boards, native sim. It can be built and it runs sort of on a PC. It's like an emulator type thing, or simulator, I guess, for sim. And then the tests can run against that. So first we need to get a build that has the new thing that we just added actually in it. And one of the things I set up last week was containers, a container for this. So there's this container file which you can use with Docker or Podman to create a container. There is this run container script which will either start or run your container. This does actually, it's set to Podman, so you do need to use Podman or else you have to change it over to Docker. Because those are slightly different things. One of them just creates it, one of them just launches it and goes into it. And then there's also a init, which you run the first time that you load into the container, and it basically loads all of the requirements that you need in order to build the Zephyr native sim. It installs all the requirements needed. It does the West SDK update stuff. It pip installs a bunch of things. So you run this once, it installs all the stuff you need. And then from then on, you can just use this run container thing. So here, I'm going to make a new terminal for it, but we're going to go ports, Zephyr. We're going to go native sim build run container. And I have already built the container. I've already done the init thing. And so it's already like cached and it's super quick and it just drops me right in. So now my terminal here is inside of that container. But we are in a copy of the same repo. So the repo that we're working on gets mounted in. So we have all the code and stuff here. And we can make the native sim build by going make board native sim. We should do a clean first because it has an old one. But then we can do build and it will make the native sim inside of here. While that is running, I am going to take a peek at the tests for basics. Is bus.io in here? We want to find the test that covers bus.io. There's audio bus.io. Got test I2C. This doesn't use bus.io, but this must be what we want, I think. Okay, this doesn't contain the string bus.io, but it's using it because that's what this object is. Okay. So the way that these tests work, generally there's like CircuitPython code here, right? This looks pretty familiar to anyone who's looked at CircuitPython code before. It is inside of triple quotes, because it's actually as a string inside of a Python script. This is a PyTest script. So what the thing will do is it will load this code on the board, the native sim, and then it will run this PyTest. What do they call those? Case, maybe? Test case function? Whatever. I'm not sure the right term, but it will run this function, which basically has a test, and the test will execute the CodePy. It will get the serial output from the native sim, and then it will make assertions about stuff in the output. So in this case, it's trying to test I2C. It's going to make sure that that some I2C devices show up. It's going to make sure that this particular address has been printed in there, and it's also going to make sure that it made it all the way to here and printed done. Like if there had been an exception or something up here, then of course it would have raised an exception. It never would have executed this code, which means this would have been ending up as false. And so this one is testing the scan. This one is testing the read code. All right, and we got our build here of the native sim. I don't I think you can run it live, but I haven't really messed too much with that, so I don't know how to do it off the top of my head, but we can run tests inside of it. So for instance, the test that I'm looking at right here, test I2C, I can go pytest, tests, test I2C, and then this will run all of these tests we've just been looking at. Each one of these green dots right here is one of those tests, so 4 of them passed, and it only took 1 second there. So it just ran through and did all of these things. And they're all structured the same, where they have CircuitPython code, and then they have a test function which will execute the CircuitPython code, read the serial output, and assert some stuff about it. So it will basically assert that the print statements did what they would be expected to do if the code was behaving as it's supposed to. So it would appear that there is just a thing connected, sort of simulator connected. I'm not super familiar with what this is, but by the name, I'm guessing it's just a little memory chip. Yeah. Okay, EEPROM. Just can store data. You can write data to it. You can read data from it. Let's say read only, but I mean, you can, somehow you can program it. So what this test is doing is getting the I2C bus, locking it, has an variable for the I2C address. It creates a buffer, just a byte array to hold a single byte. It is basically doing, I think, a read, write to, then read from. So it's writing 00 to that address. Is this an I2C address or a register? I think it doesn't use registers, actually. I'm not sure. So it basically writes a 0. It is going to put the result in the byte array. It's going to get the value, the actual single byte, back out of the array. It's going to print it. It is going to say this, a fresh EEPROM should have FF inside of it. So as long as that's true, then it's valid. Unexpected would be anything other than FF. So it will print that. Yeah, I think write to, then read from. This is actually basically just a sort of a read operation, essentially. In order to read, you have to write first to tell it which thing you want to read. So I guess we're telling it we want to read byte 0, or maybe read starting at 0 or something. Something like that. Okay, and then that's going to check that stuff, device disable, and then communication fails. So interestingly, there's no separate test for writes other than this thing. Okay. Okay. So I think what I am going to do we're inside the CircuitPython repo, Zephyr. I don't know if this is strictly necessary, but I feel like it's probably helping. Inside the Zephyr port directory, please look at tests, test I2C .py, and then make a new test at tests, test Adafruit bus device.py that will validate the functionality of the Adafruit bus device core module. should use the communicate with. All right, so it will look at that test. Presumably, it will also probably look at the Adafruit bus device. Core module. Find mpconfig h. Yeah, you can do that. Whoa. Got a little crazy on the output. Oh, geez. That's interesting. Another find. Yeah, I guess we can. Oh, well, it's saying xargs cat. I don't know what xargs cat does, actually. I should mention this is running on a Raspberry Pi that's sort of like segregated on the network and doesn't really have access to much else. And I'm actually running it without sudo as well. Lots of these agent ones are set up to where they have sudo access, but I don't really like that too much. I've set up like a sub user. I essentially treat the user that runs the LLM agent the same way that I would treat a user with a web server that's open to the public internet in it. Like, assume that people will try to abuse it in every way that I can imagine and lots of ways that I can't. And behave accordingly, lock it down accordingly. I guess, but it's kind of not super relevant. It might be freaking out because of the fact that it's not actually enabled in the local code. Like one thing that I'm having here that's weird a little bit is I have an instance of CircuitPython on my PC here, which is where I've enabled it. And then I have an instance of CircuitPython repo inside the Pi here, which is where Claude's looking at it. It doesn't actually, they're not linked up. So when I make a change here, it's not reflected in what is on the Pi. It's not reflected what Claude can see. So it sees me asking, hey, please write this test for this module. And then if it looks around enough, it's going to be like, that module is not even enabled. This test is never going to work. When in reality, I kind of want it to like just write the test assuming that it's enabled. And it may eventually get there, but I feel like checking through AES and checking through the git diff is basically it, like discovering the state of its repo, even though that's not super necessary. What's up, Tyth? Hey, Tim. So if it's all on lockdown user account, does it make sense to use Claude dangerously skip permissions instead of allowing each command? It would. I mean, to the extent that you want it to go faster without having to like click through each one, it would make sense. I tend to start with just running it normal, and then most often when I'm just like in random development mode working on stuff, I'll usually go to the number 2 down in the permission list or whatever. So it's usually like it's asking for the first time it does each thing. So it'll ask like when it first reads, it'll ask when it first writes, it'll ask when it first, runs like grep or something. And then I'll choose like always allow this command inside this session. And so after it's kind of done everything once, then it stops asking. Totally could run it with that. I just sort of still like to be able to check the at least the first couple of things it's doing and make sure it's not going too far off the rails. I've also found sometimes it's nice to have it asking, because sometimes it's like trying to do stuff that I don't want it to necessarily, like this git diff stuff. Sometimes it will start running stuff like this, and I'll just be like, no permission for that one, and then I'll tell it afterwards, like, don't worry about that, just try to do the thing without it. All right, so it says it created this. It has a success, a fail, a disabled, a read into separate with write plus read into inside one block, a write then read into atomic, a round trip, some buffer slicing, some fails when the device is disabled. And then, yeah, see, here's what I was saying. Is it's like, this test is never going to work because this thing is not enabled. And did it modify this? Yeah, I guess I told it to modify this last time. Yeah, that's all fine. Yeah, sometimes that's, I will say I've had better luck with it not worrying about this kind of stuff when I tell it like, hey, I'm actually working in a different copy of the repo on a different device, and then it's a little bit better about being like, oh, okay, he's probably just already done that. I'm always not doing that as I'm curious what's happening, but I do use 2 to go along. Just curious if anything ever gets denied. Oh, thanks. Yeah, I've never seen anything get like outright denied. Like I've never seen it try to use sudo for anything. I've never like asked it to install anything with apt or anything, but I've never seen it actually try to use sudo and fail. I do know that it doesn't work because I've gone manually into its account, which I log into every time I use it, and I can try like sudo whatever, and it won't let me. It's not in the sudoers group, and it doesn't have a password either, so it can't like pass the password check. There's like no way for it to. Actually, I think I gave it a password at one point. I don't know what it is anymore though, so hopefully I don't need it. Okay. But supposedly it will have written a test, and then what we can do is I'll just copy this out to my computer. So it's kind of a little bit of a janky workflow, but I don't like to have the CircuitPython repo that I'm actually building inside of on the Pi, because the repo gets rather large when you start pulling submodules and actually making builds. There's kind of a lot of stuff in it. In the Pi, I have only like I think 16 gigabytes maybe SD card, which is already getting sort of on the full side. Oh, I bet you the bus device resume session might be inside of here. Too late now, we already went through that and solved it again. Forgot that I made a CircuitPython Zephyr. So this command that I just ran a second ago basically mounts it so that I can access the files that are on that Raspberry Pi that the Claude's running on it. I can access those as this like mount thing here. So pi mount comes through to the agent's home directory, that sub user that doesn't have sudo. It has a subdirectory, and that gets mounted right here, so I can go in and grab any of the code that it writes. Sometimes I'll actually have it linked up to where I open my PyCharm to its files, and then I'm actually looking live at it, but I just don't do that with the CircuitPython repo specifically since it gets so big. Bus device. So grab this. Goes into tests. Nope, that's the wrong tests actually. So there's a tests in here, but that's not what we want. We want this one. And then we can try to run it. So, well, let's look at the code first. I'm a monster. I tell it to use sudo -s with raw password over SSH. But I've been bitten enough by rm remove item, so that's bash rm star is denied. Nice, yeah. Rather do a manual cleanup, but let it blow away. Yeah, I'm with you there. The cleanup. I definitely do not trust LLMs enough for any kind of cleanup task. Anything that involves deleting, I'm a little bit like, maybe let's not give it the ability to do that. I can see the appeal of like not having to sort through stuff yourself, and I could even get behind using an LLM to sort stuff, like flag a bunch of things that you think are okay to delete and just write them to a file or something, and then I'll go through and decide if I actually agree, and then I'll be the one to delete them. But yeah, I've definitely seen too many hallucinations out of the LLM and already heard too many stories of like, I was using it to clean up my inbox and it started just deleting everything important, or using it on a code base, and it's just like, let me just delete this whole section of the code because I don't feel like keeping it or whatever. All right, we can check these out. So probe is going to create an I2C device. It is going to, that's it actually, it just creates it, and then it de-inits it, and then it calls done, and the only thing then the test would do is check to make sure it got created and that it finished. This time it will create it, and it will fail because nothing has that address. This time it will create it. It would fail if it was going to probe, but it has probe false. I didn't even know that was a thing. Possibly it's not a thing. We should not just assume that it's actually a thing just yet. So here, basically, it would create it, but not actually care that it's not connected, which is odd. I'm not sure why the API supports that. This one, read, okay. And this is where it was talking about before it split them. So this does a write first and then a read, like two separate calls. And then this one here does a, yeah, so amusingly, it calls this write then read into, oh, write then read into separate, I see. But then this one here, it does the single function that does both. And it puts the 0, 0 into the output buffer. Oh, actually, it just uses two different buffers. Write then read into atomic, so those happen at the same time. Write then read back. So yeah, this one, the other test was not actually doing, I noticed. The other test was never like putting data into the EEPROM and then confirming that that data comes back out. That's what this is doing. Payload, it has 4 bytes. It's going to put those 4 bytes into the EEPROM. Then it's going to go and try to read those 4 bytes back out of the EEPROM and confirm that they came back out the same way as they went in. So that's what that one does. And then slice. So this is just going to test the slicing. but I don't see it in use anywhere. So it's got some data. It's got a destination array. So write then read into. Oh, these. Okay. This is telling it where to start inside of the arrays, inside of these buffers. So out start at index 1, end at index 2, and then in, I think, is all the way. Basically, it will skip the 0th index, I think. And then I guess it's going to validate that that worked successfully. Then there's buffer slices. Oh, no, that's what we tested up there. Sorry. Disabled is next, which disables the EEPROM and then confirms that this fails as expected when the EEPROM's not working. Yeah, okay. So those all look reasonable to me. The probe false thing, again, I didn't know that was part of the API. So we'll see. All green. Look at that. Good to go. I kind of want to go check that now. So what do the docs say about that? Probe for the device upon creation. Defaults to true. So presuming that you pass false, like what happens next? You're allowed to create the object even though the device is not there. Does it probe for it when you then call one of the communication functions? Or does it just assume it's there and then fail when you call one of these because it's not there? I wonder. And I guess secondarily, like, what would be... Is there a scenario where this would be helpful somehow? Probably. But I don't know what it is off the top of my head. Okay, so we have enabled it here. We tested it on the Feather RP2040, and that was working successfully. We have now got some tests that run on the native sim. Those are all passing. In order to get the PR ready, the next thing that I would need to do is build all of the boards, because each board has this auto-generated file which basically has booleans for any of the modules that are enabled. So enabled modules say true, disabled modules say false. And this gets auto-generated whenever you build that board. So when we enable a new module like this, I'll run build all, and it will build all of these auto-gen files, and I'll include those in the PR. I'm not going to do that on the stream because it really actually kind of hammers the crap out of my computer. But I'll do that. I'll take care of that part later. That's basically the last step for getting this ready for a PR. One thing I will do, I think, is commit locally here. Would like to commit locally. Avoid on unscannable devices, e.g. the I2C thermocouple device, MCP something, it NACs rather than ACS or something like that. Others stall on scanning, etc., but commands work if no scan first. I gotcha. Unscannable. Okay, so some devices don't play nicely with a probe, essentially. Huh. I2C, the more I learn about I2C, the more I realize it's like sort of the Wild West of... It kind of has a loose structure, but different chips are also kind of just like, you know that loose structure? We do it differently than that, slightly. Or a lot. Okay, so now that's committed. One thing I would like to just triple check here is if I go back to main and I make my Feather build again. And we put it back on the Feather, this should be without Adafruit bus device, so it should fail if we do not have the Python implementation. This will make it absolutely super duper 100% sure that when we tested on the device, we were for sure testing the core implementation. Because if we load this version of CircuitPython that I'm building right now, which will not have bus device enabled, because I switched back to the main branch, we load this one and that code still works, that means that code was not correctly actually using the core instance. But what I think will happen, and what should happen if everything is as I believe, is we will load this one and the code will fail because it will try to import bus device and it can't find it. Yeah, okay, and I just verified here it's not in this list. This is the list where it basically pulls the ones that get enabled. So this is the list where it pulls the default ones that get enabled. There's more logic further down that pulls in different ones based on networking and some other things, but okay, here we go. We gotta build. Go to bootloader mode. Actually, I'll just up that a couple of times. There we go. No module bus device. Cool. Okay, so yeah, for sure, we enabled it and it works. We know we're testing it because it can't import when we don't have the build without it. And it's working on both the device, the physical device, and the native sim. And I will swap it back to the one with that enabled, just because that's more fun. But that is going to be about doing it for the stream. There are a couple minutes left. If anyone has questions, comments, concerns, riddles, anything else they would like to share. Yeah. Perfect timing as well. I've made it through approximately 1 cup of coffee. Yeah, well, this build is running. I will just kind of talk a little bit more about the tests. I think this idea of being able to test in the native sim like this is super cool. So like hug report to Scott for setting this thing up. The ability to kind of like have some Python code, run it on an actual device, a simulated actual device, and then have a PyTest that validates the response of it. I will draw a parallel to something that I've been working on. Is it agent skills? So inside this agent skills repo is where we're kind of like, it's a repo to share Adafruit related skills for agents. So I've been filling in stuff in the CircuitPython folder. There is a hardware test runner, HW test runner, which is a similar kind of thing as that native sim test thing. So this is also running CircuitPython code on a device. In this case, though, it actually runs on a real physical device that's connected. And then that code is expected to print certain things like pass fails for different tests. And then this will validate the output. So the overall flow of like, here's some test code to put on a device. We're going to run it on a device. We're going to read the serial output, and then we're going to validate that the code actually did what it was supposed to based on that output. This is also doing the same thing, but it's doing it on a hardware device using the CircuitPython runner, which basically is just a Python script that connects over serial, enters the REPL with Control-C, then it copies the files to it, then it runs the code with Control-D, and then it reads the output with PySerial or whatever, PySerial. And so this runner script will run and give you back the results, and then this test script will use the runner to run all of the tests that it finds. And there's like a folder that I've been adding. So if we look in the Max repo, I will say these ones aren't ready to go yet, but I did commit them anyway since they're here. I need to fix a couple of things in them. But we're adding these hardware tests folder now for the new drivers. So that test script will find all of these and execute all of them the same way that the native sim one does the tests inside of here. So I think this is a really powerful way to be able to like validate that this one for the native sim is validating that the core works, that the Zephyr modules are behaving as expected. And this one out here is being able to validate the drivers that I'm writing, because as I get like the max 4409 driver, we have these tests that will actually validate, like, does the lux go up when you turn a light brighter? Does the interrupt actually fire when you cross the threshold? Different stuff like that we can validate with hardware, but still automatically. All right, we're back to a good build here. I'll put this back on the device, but then we are wrapping it up. Copy that. And we should start seeing some Lux numbers streaming back into here. But that is going to do it. Thanks everyone for watching. There they are, so we're good to go there. Thanks everyone for watching. I do hope you all have a great week. Do remember, can get back to the browser tab. JP's product pick of the week is coming up later today, 4 p.m. Eastern. That is in approximately 4 hours from right now, by my math, which not guaranteed to be correct, but 4 p.m. Eastern one way or another. If you come back to this channel here on YouTube or Twitch or wherever you're watching this, you will find JP doing the product pick with a fantastic discount on this week's product pick. So thanks everyone for watching. I will be back next week at the normal time, Tuesday, 10 a.m. Central Time here for a deep dive. I believe Scott is going to be around on Friday for his deep dive. Yeah, so thanks for hanging out. I will catch you next time.